Hey guys, okay, so we're going to look at how to balance reactions. So let's say we have a reaction of Na plus Cl yields NaCl. Okay, so we would look up, let's say if we wanted to write this out, we would look up sodium and we find it in group 1, so we know it has a +1 charge. We would look up chlorine. We'd find it in the -1 in the group 7, so it's -1. We would crisscross the numbers, which you guys should have a good feel for by now, and we would get NaCl. Okay, now in the law of conservation of mass, it tells us that everything that we put into a system, we should get back out of a system. Okay, and we've talked about that with some other things as well. Like energy, we talked about potential energy and kinetic energy having to equal each other, because any energy that we potentially can have has to be converted and used up somehow. It doesn't just disappear, right? And we can't just make something out of nothing. So the same idea applies here when we're looking at chemical reactions. So basically what the law of conservation of mass tells us is that we have to have both sides of an equation, a chemical reaction, balanced. So how we do that is we write numbers in front of the elements or the compounds. We cannot change these numbers right here because this is a subscript, right? It doesn't have anything to do, we can't change it. This 2 here, does anybody remember why this 2 is here? I'm going to pretend like you guys are going to answer me because you're with me. This 2 is here because, if I can get my eraser to work, let me do my finger. Because it's a diatomic chlorine. Remember how chlorine is a diatomic? If I can get this thing to work. Sorry, hold on. Yeah, okay. So chlorine is a diatomic, and that's why it has that number 2. Remember I told you guys you don't really technically have to memorize them, but you kind of need to know them. Okay, so if we break these apart and look at them, here we have 1 sodium atom on this side, and we have 2 chlorine atoms on this side. And this side is called, what's happening here? Everyone is, okay, let's see if that comes back. Okay, so on this side is called the reactants. And this side is called the products of a chemical reaction. You guys have probably figured that out by now from your videos and the book. So we see that we have 1 sodium on this side and 2 chlorine atoms on this side. And on this side we have 1 sodium and we have 1 chlorine, right? Okay, so these already match up, but chlorine does not match up. So we have to make them match. Okay, so how we do that is we add coefficients. Coefficients are big numbers that we put in front of the letters, like in math, a coefficient. Okay, so we're going to put a 2 right here because we cannot put a 2 right here in the middle of a compound. It has to go in front of the entire thing. Okay, and by doing that, we switched, and now we have to do our math again. So now we have 2 sodiums and 2 chlorines because I did 2 times 1 for sodium and 2 times 1 for chlorine, so there's 2. All right, now we fixed our chlorine problem here, right? But we messed up sodium. So in order to fix the sodium, we have to make the other side have 2 as well. So we can do that by just putting a 2 in front of sodium. Okay, so now we can change our numbers over here. And we can say now we have 2 sodiums and 2 chlorines. And now we can see that the reactants and the products both match. So this is balanced equation. Okay, now let's look at another one. Okay, let's say that we have beryllium plus oxygen yields beryllium oxide. Okay, because this is a +2, this is a -2. If we crisscross, but we always pick the least common multiple, and they both are 2, so we can just put one of them on each side. Okay, and now we can see if they're balanced. So we have 1 beryllium on this side and 2 oxygen, and 1 beryllium on this side and 1 oxygen. So we can see that oxygen is not matched up. So in order to fix that, we're going to fix the oxygen and put a 2 right here. And then we're going to go on the other side and we're going to put a 2 right here since we messed up beryllium. So now we're going to go ahead and check now our numbers and see if we're good. Okay, now we have 2 beryllium and 2 oxygen and 2 beryllium and 2 oxygen. So this is balanced. Okay, so hopefully you guys are kind of seeing how this works. Let me show you, let's see, let's do another one. Okay, let's say we have, okay, so let's say you're given like a word formula, like let's say, oops, we have hydrogen plus oxygen yields water. Okay, so if we want to write this out, we would say H2, because it's a diatomic, plus O2, because it's a diatomic, yields H2O, water. Okay, so if we look at this, we see that we have 2 hydrogens on the reactant side and 2 oxygens. And if we look at the other side, on the product side, we have 2 hydrogens and 1 oxygen. So if we go ahead and fix the oxygen and put this here, now we have 4 hydrogens and 2 oxygens, and then on this side we have 2 oxygens and we have 2 hydrogens. But we need to have 4 hydrogens, so what should we do to make 4 hydrogens? We can just put a 2 in front of this hydrogen, okay? Now remember, you cannot take away this number right here. This is a subscript and it cannot be changed. Just like this one here, because in a compound it represents the oxidation number of the other element, right? Because you crisscross them in order to get the subscript. So we cannot change the subscript at all. We can only add coefficients. And another thing students try to do that you cannot do is you cannot put the coefficient in the middle. That does not work. You have to put it in front of the entire compound. It has to be done to everything in the compound. Okay, so let's look at one more, and then hopefully you guys are getting the hang of it. And then I gave you a homework sheet with the answers. So there are 2 on the homework sheet that are a little bit more challenging that you may have to use the answers to help you. But what I can tell you is the very best way to balance when you end up with a lot of things is to do hydrogen and oxygen last and do the things that are by themselves last. Because then you can just put any number in front to be able to balance it. Okay, so let's say we had iron plus oxygen yields iron 2 oxide. All right, this was iron 3 that we had. Okay, so we look here and we have 1 iron and 2 oxygens, and here we have 2 irons and 3 oxygens. Okay, this is not balanced at all. So you might think, okay, let's fix the iron first. If we do that, the only thing that's bad about doing that is iron is over here by itself. See right here in the reactant side? We could put almost any number in front of iron and we'll be able to get it balanced. So I think it would be easiest to leave iron last because all we have to do is put a number in front of it. So see, that's what I mean by kind of looking for the ones that are by themselves, or oxygen or hydrogen sometimes by themselves, and then leave those for last because sometimes it's easier to balance those by themselves. And then also, we also need to make a note that this is an even number. And no matter what we multiply by this number 2, we're always going to get an even number for an answer, right? So when these get a little more difficult and you're trying to figure out how to get the reactants and the products to match, if you have one number on one of the sides and no matter what you do, it's always going to be an even number, then you know for sure you have to figure out how to make this odd number an even number in order to get the answer. So we're going to try a 2 here, okay, because that will make our oxygen even. And we need our oxygen to be even in order to balance it. Okay, so if we have a 2 there, then that now gives us 4 irons, and 2 times 3 is 6 oxygen. So we have 2 times 4 is 2 times 2 is 4, and 2 times 3 is 6, okay? And if we look at the other side, let's see if we can change that. Let's see, to make oxygen 6 on this other side, we could put a 3, and that will give us 6. Okay, and then iron, there's 4 irons here, so we could put a 4, and that will give us 4 irons, and then it's balanced. Okay, so like I said, some of the ones you have for homework are really easy and similar to these, and then some of them are a little bit more difficult. So just try to do the best you can. Try to use the answer sheet the least amount possible to see if you're getting it right, and we will just go from there. Okay, let me know if you guys have any questions while you're working.